In this video, we'll be solving systems of equations using elimination. Our first example is to solve the system 4x minus 3y equal 14 and x minus 2y equal 1 using elimination. The first step is to rewrite one or both of the equations so that the coefficients of one of the variables are additive inverses. Now what that means is, for example, I could change the y coefficients to 6 and negative 6. Those are additive inverses, and when I add them, they would eliminate each other. They would go away. That would require that I multiply both equations by a number to get our 6 and then our negative 6. What I'm seeing here with this variable is that if I multiply down here on the second equation by negative 4, that would give me additive inverses for the x coefficients, and I wouldn't have to do any multiplication on the top. So I'm going to go ahead and change the coefficient of this term to a negative 4 so that when I add these two together, they'll go away. So that means then that I'm going to multiply this equation by a negative 4. Let me copy my top equation down. 4x minus 3y equals 14. And then when I multiply negative 4 times x, I have negative 4x. And negative 4 times negative 2y is a positive 8y. And then don't forget to multiply the other side as well. Negative 4 times 1 is negative 4. Now I'm just going to add those two equations together. And when I add 4x and negative 4x, those terms cancel, which is the reason it's called elimination. Negative 3y and positive 8y is 5y. And then 14 minus 4 is 10. Solving for y, I divide both sides by 5. And y is equal to 2. Once you have the value for y, then you need to put that back into one of the equations that you started with. I'm going to go ahead and put it in the second equation. It doesn't matter, really. X minus 2y equals 1, and I'm going to put this 2 right in here for y. So I have x minus 2 times, and then in place of y, I'm going to put the value 2 equals 1. So I have x minus 4 equals 1. Add 4 to both sides. And these cancel off, and I get x is equal to 5. So the point where the two lines intersect, these are both linear equations, the point where the two lines intersect is the point 5, 2. Now, since there is a solution to this system, it is consistent. And since you can't get one equation by manipulating the other one algebraically, they are independent. Do another example. So in this example, we're going to solve this system using elimination. Again, remember you want to rewrite one or both of the equations so that the coefficients of one of the variables are additive inverses. Now if we take the x variable, I could change both of these to 6, but I would need to make one of them positive 6 and the other one negative 6. I could do that. This one already has opposite signs on the coefficients, so I'm going to choose to change these numbers to 6's, and since they already have the opposite signs, I don't need to worry about that. So to get a 6 on this first y term, I need to multiply by 2. And then to get a 6 on this y term, I need to multiply by 3. Remember, you multiply both sides. Let's rewrite this equation with the 2 multiplied through. So 2 times 2x is 4x. 2 times 3y is 6y. And then 2 times negative 1 is negative 2. Let's rewrite the second equation, multiplying the 3 through. 3 times 3x is 9x. 3 times negative 2y is negative 6y. And then 3 times 18 is 54. My next step is to add the two equations together. Notice that the positive 6y and the negative 6y are going to cancel each other off. 4x plus 9x is 13x. 54 subtract 2 is 52. Divide both sides by 13. And these cancel. And x is equal to 4. Now we still need to find the y coordinate that goes with this x value. So I'll put it back into one of the equations. It doesn't matter which one. I'll just put it into the top one, the original one. So I have 2x plus 3y equals negative 1. And we're putting 4 in place of x. So I have 2 times 4 plus 3y is equal to negative 1. 2 times 4 is 8. Plus 3y equals negative 1. Subtract 8 from both sides. 8's cancel. And I have 3y is equal to negative 9. Divide both sides by 3. So those cancel and y equals negative 3. So my point where these two lines intersect, they're both linear equations. The point has coordinates 4, negative 3. Since there is a solution set for this system, it's consistent. And since you can't get one of the equations by manipulating the other one algebraically, they are independent.